Alright, we're starting with central angles and parts of circles. The first one's central angle, angle whose vertex is at the center, and it'll make more sense when you look at the diagrams. Semicircle is an arc with endpoints that are endpoints of a diameter. All that means is half circle. And you'll see it when you see the picture. Arc is an unbroken part of the circle. A minor arc is less than 180. A major arc is between 180 and 360. Why does it need to say between 180 and 360? What happens if it's 360?
It's all the way around.
That's the whole circle. I don't want the whole circle, I want part of it. Measure of a minor arc is the measure of the central angle. Again, it'll make more sense with the pictures. And the measure of a major arc is the difference between 360 and the measure of the related minor arc. All that stuff will make way more sense when we look at the pictures. Everybody good there?
Yes, sir. Whoa.
All right, congruent circles, they have the same radius, which means they're going to be the same size. Congruent arcs have the same measure, and are arcs of the same circle or congruent circles. In other words, just because the number is the same doesn't automatically make the arc the same. It's got to be the same size circle for that to work. All right, here are some diagrams of what they look like. Central angle has its center at the vertex, or excuse me, has its vertex at the center. So when the angle goes to the center of the circle and comes back out, that makes it a central angle. An arc will be like this highlighted portion up there. It's just part of the circle. And a semicircle is half the circle. And look at it this way. If you have one semicircle, what do you really have? Two semicircles. Because this one's going to be 180 just like that one's going to be 180. All right, minor arc, definition said it was less than 180. In other words, less than half the circle. So these two on the left over here are examples of what minor arcs would look like.
Coach, can you slow down a little bit? Because I'm over here to drop our circle. You over here to get to a whole other page.
If we wasn't talking so much, we wouldn't be there. I'm trying to do this. So the two on the left are going to be minor arcs because they're less than 180. The two on the right are going to be major arcs because they're more than half the circle, but they're not the whole circle. Right? And what you need to realize in this, for every minor arc that I have, I also have a major arc that goes with it. Does everybody see that on the first one? I got the highlighted minor arc, but then if I look at this, what would that one right there be? That would be a major arc. So every time you have a minor, you actually have a major that goes with it on something like that.
Hold on.
All right, for a minor arc, you normally use two letters to do it. And everybody listen to this next part. For a minor arc, you always go the shortest way possible. So on this first circle right here, if I'm talking about arc BC, I've got to go that way. It's got to be the shortest way possible. So if you've got two letters, you go the shortest way you can possibly go. BDC, on the other hand, if it gives you three letters, that's almost always going to be a semicircle or a major arc. It doesn't have to be, but most of the time it is. So arc BDC, I start at B, I hit D, and then I finish at C. Does that make sense? Follow the letters when you're talking about the arcs. If I go to the second one over here, ZV is this little one at the bottom. VY is that little one right next to it. What kind, let me go back to the first one. What kind of arc is BC? Minor or major? Minor, because it's less than half the circle. BDC would be major because it's more than half the circle. If I come over here to ZV, minor or major?
Minor.
ZV is small, less than half, so that's a minor. What about VY? It's still minor because it's less than half. All right, what about ZVY?
Major.
Look at it now.
ZVY.
ZVY goes from Z to V to Y. That's as far as it goes. It's still less than half the circle, so even though it's got three letters, it would still be a minor arc.
Hold on, Cole.
All right, when we're talking about arcs, make sure you put this little symbol above it. A little curved line on top. Whenever we're talking about arcs, you need to put that little symbol above it. Because if you don't, what does it mean?
It's just BC.
If I give you that, what does BC mean? Yeah, line segment. This is part of a line segment. Or this is a line segment. So it's got to have a little curved thing above it to know we're talking about arcs. Alright, when we're trying to find the measure of the arc, that's the number of degrees it would take to go around the circle. How many do we have total for a circle?
160.
360 for the total circle. Alright. Back here, the measure of a minor, or where is that? It's not wrong. Measure of a minor arc down here says it's the measure of the central angle. Central angle again is when it goes to the center and comes back out. So if I'm looking at this one for BC, which is this part right here, it matches what central angle inside there? 40. So then that means BC has to be 40 degrees. All right. The next one is CD. So that means again, I'm going to start at C. And I'm going to finish at D. Go the shortest way possible if it's two letters. How many degrees would that be? Not from C to D. 140. Why?
Because you would take half.
What is that right there on the top part?
180.
That's 180. So I know if that part whole from D to C to B is 180, and I take off that 40, 180 minus 40 would leave 140 for CD. If I go to BCD,
180.
well, that's a semicircle. So that's got to be 180. That's half. All right, CDB.
That'd be
360 minus
40.
140.
All right,
Just
360
minus
minus 40.
CDB. I start at C,
So it'd be
I hit D,
320.
and I finish at B.
I thought it was CBD.
Make sure you follow the letters. So CDB in this case is everything except
40.
that 40.
320.
Well, I know the whole thing is
360.
360 minus that 40 that I don't need tells me that CDB is 320. And then DB,
180.
no matter which way you go, it's a semicircle, so it'd be 180.
Oh, I thought
All right, copy that one down. We'll go through it. If I want to start with BC, well, let me back up. The first thing you need to do on any of these problems is fill in all the central angles. How much would this part be down at the bottom?
50.
How do you know it's 50?
This whole thing.
Add 75 and 55.
I know the bottom half is 180. So I'll do 75 plus 55 and get 130. 180 minus 130 leaves 50. I'll fill that in. Another thing that you should check for is any vertical angles, because vertical angles we know are equal. So which one is vertical with this 55?
The one
Over here. So that makes that easy to fill in. Matter of fact, I'd probably do the vertical angles first to make it easier on myself. Then the only thing that's left is this one over here.
125.
So I would cut out the bottom ones and not look at those and say, well, if this is 55 here, I would do 180 minus 55 and get 125 for that part. So that's always the first step, is to fill in all the central angles. Once you have those, then we can start doing the measure of the arcs. So BC, again, I'm over here.
55.
I want to match it with the central angle. Well, the central angle for BC is
55.
55. CD
125.
is 125. And what kind are these? Let's go back and do that. What kind is BC?
Minor.
Minor. What kind is CD? Whoa,
Minor.
less than 180, still minor. All right,
We got a name?
yep. Name them and give the measure of the arc. CBE. All right, here's where people start getting confused on some things. The way to solve these is to go around the circle. You never go through the circle for an arc. So CBE means I start here, I go around the B, and I finish when I hit E. Do not go through the circle.
That'd be 180.
So that should be easy to see that that's 180. What kind is that?
It's on major.
No,
Minor still?
no, 180.
Oh, semicircle.
Semicircle. All right, BE. What kind?
It's a minor.
Minor, because it's less than half. And it would be the 75 plus the 50. So that's 125. CEB. Again now, remember, you start at C, you go until you hit E, and then you finish when you get to B. You got two choices on this one. You can add up all the parts that do work, or you can say, which part do I not need? I don't need the 55. So I could do 360 minus 55. Or I could add up 125 plus 55 plus 50 plus 75. Whichever way works for you. I don't care which way you do it. The fastest way is to do 360 minus that. You get 305. What kind is it?
Major.
It's a major. Alright, see if you can do 6 through 10 on your own. EDF. What kind is EDF?
Major.
That's a major.
That's through 10.
And it's everything except that 50. So I do 360 minus 50. DE, what kind?
Minor
And
is 55.
matches the central angle. BDC,
Major.
Major.
that's
That's
major.
105.
305.
105.
305.
BDC now. I go from B, around D, hit C. CDF. What kind?
Major.
And
230.
30.
Teachers, excuse interruption, but when the bell rings from the lunchroom.
All right, DEF, real quick. What kind?
105. That's major.
Oh, minor. 105. Less than 180. All right, if we change the numbers like we got here, and we want to do this one, what do I need to start with?
Vertical.
I'm going to do vertical first to make that 65. Now what?
180 minus 65.
180 minus 65 will give me that top one right there.
115.
115.
Other one is 55 degrees.
I'll take the bottom part and I'll say 60 plus 65 is 125. Subtract that from 180 and get 55. Fill in all the central angles first and then we can do the numbers. BC.
Minor.
65.
Minor and then 65. CD. Just do the number 115. CBE is still a semicircle, so that's 180 no matter what. BE, I'm gonna add up those two parts, 115. CEB,
180.
remember, go around the circle. So CEB starts there, hits E, finishes at B. Never go through the circle for an arc. So CEB would be 295, is that right? EDF would be the 300 because I don't need that 60 down at the bottom. DE, 65, matches the central. BDC,
295.
everything except that 65 right here. CDF, 240. And then DEF, 125 because I'm adding up the 65 and the 60 right there. All right, what you're checking for on this, first thing, is it one circle or two circles?
One circle.
If it's one circle, then all I'm checking are the angles going to match up. If it's two circles, I check are the circles the same first before I start worrying about the angles. So on this first one, it's one circle, so that takes care of that part. Is this angle the same as that angle?
Yeah.
Why?
Because vertical.
It's vertical. So I don't know what the numbers are, but I know that these angles are the same. So to answer the question, is arc AB the same as
Yes.
equal to CD?
Yes.
It's one circle, same angle, so that's a yes.
Next one's a yes.
If I go to the second one, it's two different circles. First thing I'm checking, are the circles the same size? Then it's an automatic no. It doesn't matter that that's a 50 and that's a 50, that's irrelevant. Because I'm checking the circles first, and if the circles are different, that's an automatic no.
That's
All right, again, first thing I'm checking, One circle or two circles? So the first one, it's got one circle, so now I'm worried about the angles. Well, if this is 75 over here, and that's 30 up top, that leaves
75.
75 there.
75, 150.
So AB and CD both have the same angle inside of one circle, so that's a yes.
Now 2 is no.
If I go to 2, I check 2 circles. Are the circles the same size? And it's an automatic no. Number 3, I got 2 circles. Are the circles the same size?
Yes.
How do I know?
Because they're the same.
Look at that.
I've got a mark there and a mark there for the radius. If the first radius matches the second radius, the circles are the same. Now I go to the angles. Are the angles the same?
Yes.
There's a 90 and a 90,
Just turn it down.
so that would be a yes.